Out, guys. I believe today is Friday, October 9th, which means I'm coming back very soon. So we're going to go ahead and start Unit 2 without me, which is just polynomial relationships. Stuff you've kind of done last year a little bit, just to start, and then we'll start getting into some new stuff in a little bit. So when we think about what a polynomial is, since Unit 2 is polynomial relationships, well, a polynomial, this is your standard form, right? A sub n is just some coefficient. A sub n minus 1 is just, another coefficient. Could be the same, could be different, right? They're just numbers that go in front of the x's. X to the n minus 1. This does mean it goes like a degree order, so it's always written in descending order. So, n was 3, you take, something 5, x to the third, plus 7, x to the second, on and on and on until you just get x to the first, and then a sub 0 is what we call a constant. It doesn't have any x with it. It's like, in a quadratic like this, you could have 5x to the third plus 2x, plus 3. So the constant would be 3. But you always write it so that the largest degree is first, and eventually the constant is last as long as it has a constant. And the degree is helpful because the degree is the highest exponent, right? And that tells you how many roots or zeros that you're going to have, right? So always make sure if you have to answer a question about zeros, look at the degree, make sure you have the same amount of zeros. And we can get into double roots and stuff, so this one root counts twice. We'll be doing that in a little bit too. So this is standard form. So types of polynomials, right? X plus 2 would be an example of a linear polynomial. X squared plus 5x, right? That's quadratic. X to the third is a degree. You don't have to have an x squared. It's still x to the third is a degree of 3. That's cubic. And, we have something like x to the fourth. That's quartic. And then x to the fifth, you might guess, is going to be quintic. So, and then it goes on and on and on. I could have x to the 100th and it's still a polynomial, right? So when you're thinking about 2.1 as quadratic polynomials, which I know we beat to death last year, so very short slides, right? This is our standard form as we refer to it, ax squared plus bx plus c, and then vertex form is a, and then x minus h squared plus k. However, when you do the book work tonight, if the book work says standard form, it actually means vertex, right? The book thinks the standard or basic form is actually this form right here. So if you see tonight's homework, standard form, you can use vertex form. All right, so potential questions that you could be asked. You could be asked to find an axis of symmetry, right? If we remember from last year, the axis of symmetry is x equals the x-coordinate of the vertex, right? So you could use your max-min button to find the vertex, and then only look at the x-coordinate, say x equals that, but you want to make sure it's an equation as x equals. A vertex, simply just by doing the max-min button, it gives you the x and the y, so the vertex is the x comma y. The y-intercept, if we remember, that's our value button, right? So it's all second trace. That's the menu option. So if you hit value, just hit 0, right? Because that'll tell you the y value anywhere you set the x equal to. So obviously, if it's a y-intercept, the x value would be 0. Your x-intercepts are going to be found by going left bound, right bound, using the 0 button. Unless you were somebody who really liked to graph, a second line as y equals 0, and then we did the intersection. I think maybe Miss Radzek or Miss Willie did that. But I think for our class, we did left bound and right bound using the second trace, and then the second one down was the 0 button like that. Potential questions, right? This is the only other question you guys might have an issue with in your homework. And I said something along the lines probably last year to you guys where I said, you only really need to complete the square in Algebra 2. And that's still true. So this is a typical question. If it says, write in vertex form a parabola whose vertex is negative 2 comma 5, and who has a coordinate point of 0, 9, you might say, well, how do I write that specific one? And you may be able to figure it out, but for those of us who can't, right, you got to think, all right, well, the vertex is negative 2 comma 5. So it's going to be something like y or f of x equals, and then, I'll just write the standard form. So, well, vertex form. A x minus h squared plus k. Right. So what can we fill in here? Well, we can fill in the vertex, right? -2 goes right there for h. 5 is going to go right there for k. So I'm going to get y is equal to a x minus h, but minus h is going to be minus -2, so I'm going to say plus 2 squared, and then plus k is plus 5. Now this point is also good because that is an x comma y. It's not the x or the y, but it's an example. And when you think about it, if I plug in an x and a y, the only thing left that I have is a, right? And that's basically what I'm going to solve for. I can solve something that's only one variable, and that's what I need to solve. I actually need to find a instead of x and y. Those are just always in the equation. So I'm going to have y is going to be 9. So I'm going to have 9 equals, I still don't know what a is, and x is going to be 0. So 0 plus 2 all squared and then plus 5. And then from here, I can solve for a pretty easily. Right, I'm going to have 9 equals 0. Well, I got a, but 0 plus 2 is 2. 2 squared is 4. So I'm going to say 4a. And then plus 5. I'm going to subtract the 5. So I'm going to get 4 is equal to 4a. I'm going to divide by 4. I'm going to get a is equal to 1. And you can certainly check that by plugging 1 back in if you wanted, but that's it. So if I asked you for vertex form, and I gave you this, and I said, find the equation in vertex form whose vertex is this and the point is this, you would say y equals, you don't need 0 or 9 anymore. The only reason you needed that was to get the a, and you got it. So 1, but you don't actually really need to write 1 since it's understood that it's there. So x plus 2 squared, and then plus 5. Right, that vertex, that is a staple. That has to be in the equation. Right, if it's vertex form, those have to be in there. X's and Y's, that's how you kind of graph a line, is by setting them for Y and X. So you don't plug the 0 or the 9 back in there. It wouldn't make sense. What you really needed to find was an a value, which in this case is 1, so you don't need to write it, but that's it. Now, if I said, what about putting that one in standard form? Well, all you would really need to do is FOIL this out, right? So you'd have y equals, and then x plus 2 times x plus 2, and then plus 5. And then you'd probably get something like, x squared plus 4, x plus 4, you'd probably get something like y equals x squared plus 4x plus 9, and that's it. So that might be one of the only ones you have questions on. If you ever need to, if you ever think you're going to need to go from standard form to vertex form, you don't need to complete the square. All you're going to need to use is negative b over 2a to get the x coordinate. Plug that into the standard form to get the y coordinate, and then just plug in your vertex in the h and k. The only thing that you wouldn't know is a, but if it's giving you the standard form, a is the number out in front, it's going to be the same thing in vertex form. So a in standard form is the same number as a in vertex form. So you will never need to complete the square. You literally can just use negative b over 2a to find the x coordinate right there, which is the h. Plug that one in to get the k, and then whatever a is, right? So, and that's it, right? X and y are just kind of there, and you can get it that way. So that's it. I don't think you should have any other questions in that section. So you might as well start it. So your textbook problems that you're going to do for the rest of the day, 1 to 67 odds. Finish it for homework. Again, the book refers to standard form as your vertex form, so do vertex if it asks for standard. And happy Halloween. So last year when I did these slides is obviously around Halloween, or a little bit before that now, which is good.